This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. Chuck, we got an explainer today.
Yes.
It's an explainer, but we're explaining stuff that I don't have expertise in.
Okay.
So we bring on an expert.
How good of us.
Today we're talking about El Nino. With our good friend of StarTalk, Katharine Hayhoe. Katharine, welcome back to StarTalk.
Thank you for having me.
I love your title. Let me get it right here. Chief Scientist of the Nature Conservancy and Distinguished Professor at Texas Tech University. You're an atmospheric scientist, and that's how we've tapped your expertise in the past. And you specialize in focusing on how climate change can impact people and the planet. I mean, what else would you want an atmospheric scientist to do if not that? And you lead and coordinate scientific efforts at the Nature Conservancy. And I think Texas Tech, you gave you a new moniker. You're United Nations Champion of the Earth.
Nice.
We are the champions.
Yeah. Did you get a belt with that? Did you get a big giant belt?
I wanted
belt that goes along with, yeah.
No,
And
I
still
wanted
champion, right?
a Captain Marvel cape was what I was going for, and they did not deliver.
They fell through on that one. So Katharine, to this day, if someone asked me what is El Nino, I would have no way to. I don't know. So can you just put me in the same place you are, and presumably Chuck, and Chuck is already there. Chuck, you know what El Nino is?
I know what El Chapo is. I know El Chapo.
El Chapo in prison, El Chapo. Okay. Look, Katharine, just start. What is El Nino other than the literal Spanish translation of the boy child?
Well, you're very fortunate here because not only am I an atmospheric scientist, I am also fluent in Spanish. So I can take both on.
Okay.
So, El Nino refers to the Christ child. And the reason why this mode of natural variability in the climate system is called El Nino is because it would typically manifest in the winter around Christmas time off the coast of Peru, hence the Spanish connection.
Look at that.
Yes. So it is.
Well, what's it have to do with Jesus?
I'll tell you what it has to do with Jesus. We are screwed, and we need to pray.
To Jesus moment.
We need to pray. We need to come to Jesus moment. Okay, Lord, please, Jesus, please help us, Lord, help us.
Okay.
100%. That is absolutely right.
No, I don't believe that. No. So tell me why? Because when I see Renaissance paintings of Madonna and Baby, it's Madonna and Bambino, but I guess that's Italian, not Spanish, right?
Yeah, Spanish is El Nino, the Christ child. That's what they call you, El Nino. But now you know this, Neil. When Jesus was reputably born was Christmas, December 25th. But we now know astronomically that it was likely not in December.
It is so not in December. That was done. It was an attempt to gather all the pagan solstice rituals and replace it with a Christian ritual to piss off the pagans who you're trying to convert. So yeah, it has very little to do with wherever he would have, what part of the year he would have been born. I think some estimates put it in the spring. But
well, one of the things that says is that one of the angel visitations, that shepherds were tending their flock by night. And that is not something that would have happened in December. Right. So even in the scripture itself, it kind of betrays the fact that it wasn't what we would call Christmas time.
So why is it named after Jesus, baby?
Well, it's named after the Christ child because it would typically be ramping up around Christmas time off the coast of Peru.
I got you. So it's not just off of Peru for it to be named, given a Spanish name. It was because of the time of year. I get it. Okay.
Exactly. But of course, we know that El Nino affects us all around the whole world. It's just that it was first noticed and identified there. So that's where the name comes from.
All right. So we got the boy Jesus covered here. So now what is El Nino?
El Nino is one of the most well-known modes of natural variability in the climate system, where over time, we see these modes of natural variability where we have more heat going from the ocean into the atmosphere. That's during an El Nino. Or more heat going from the atmosphere back into the ocean. That's the opposite part, La Niña. But that's not the only mode of natural variability. We also have the Pacific Decadal Oscillation. We have the North Atlantic Oscillation. But El Nino is the most well-known, and it happens every few years. So every few years, we go up into El Nino, then we go back into neutral for a year or two, and then we go down into La Niña typically, and then we go back up to neutral. And what that does is it affects our weather around the world. That's why this matters to us, because when we have all that heat coming from the ocean into the atmosphere during El Nino, the globe is a little bit hotter than average, and it also affects tropical regions predominantly, as well as we get a lot of storms along the coastal area of North America. And they've even showed, for example, that civil conflict in tropical countries tends to increase during El Nino years because of the impact of El Nino on weather and the impact of weather on people's livelihoods and the economy.
Right. Their livelihoods, or just they get pissed off because they're hot? Yeah, like if you're in an airplane and the AC isn't working, people just fight, right? That's where all those YouTube videos come from. People pummeling.
Or real crime statistics, that crime goes up when we have hotter summers. Like the crime statistics show that there's a increase in violence. So yeah.
There is. But it comes off of Peru. Why would it affect the whole world? Why? I mean, I don't get it.
Well, it's actually a long tongue of warm water that reaches almost entirely across the Pacific. So it has a huge impact on Australia as well. And it isn't just temperature, it changes rainfall patterns. So some places during an El Nino get drier and other places get wetter. So it's a great example of what I like to call global weirding. Things just get weird. But then you superimpose this natural variability on top of the long-term warming trend caused by human emissions of heat-trapping gases. And that's when we get a year like this year.
Right. This year, 2023, where we have excessive heat in many places across the globe in the northern hemisphere. So how long does El Nino last?
El Nino typically lasts, it's defined, first of all, as when sea surface temperature off the coast of Peru in a box, they call the Niño 3.4 box, when sea surface temperature is more than half a degree above the long-term average. And so it typically lasts for a number of months. And then it goes back down into neutral condition. Sometimes it can last for up to a year.
So I've heard people say this year El Nino is expected to be pretty bad. Is that just clickbait, or is there extra information?
Or is the box bigger than we'd like it to be?
I know, right.
Well, they do forecasts of El Nino, and the further it departs from the average, the stronger it is and the greater its effects. So that's what we're looking at this year, is a greater departure from the neutral condition or the long-term average. But again, it's on top of this long-term warming trend. So we've got two things going on now. We've got El Nino, which often produces chaotic and very harmful weather, especially along the west coast of the U.S. And in tropical areas. But then we've got the long-term warming trend on top of it. It's like a 1-2 punch. And together, they're adding up to greater than the sum of the parts.
When was El Nino first named?
That's a great question. I'm not sure about that.
So, I mean, is there records in the 1800s, 1700s, or is it a 19th century, a 20th century invention?
It was recognized by people in Peru for some time. That's why it was already named by them by the time scientists got a hold of it. Scientists
so just use their name.
Yeah. Oh, wow. Yes, exactly. Okay.
Look at it.
So it's a great example of how people notice things.
Just the Peruvian civilization was just like, oh, look at this. It's hotter. We have this different weather trends. They just looked at it. Is that because they were agrarian society, or what caused
it would have had to have happened after the conquistadors, because there was no Christianity until Spain arrived in South America.
Well done there. Well done.
Well played, right?
But they could have been calling it something else and have it renamed. You need to have an archaeologist or anthropologist on after me to talk about that. Yeah. The coast of Peru is very dry. And so I would assume it had a lot to do with rainfall patterns. And I'm sure that people living there noticed that every few years their rainfall patterns shifted dramatically. And they probably did have a name for it, but then you're right, they probably, whatever it was, got called El Nino after the conquistadors arrived.
Yeah.
Now, scientists have only been tracking it. We track it on a monthly basis, and we've only been tracking El Nino since the 1950s. So we have records of El Nino variability, the sea surface temperature in that area going back to the 1950s.
Okay, so now what happened with La Niña? What happens?
So it's a natural cycle, which means it goes up and down and up and down. And when it goes up, that's an El Nino. And when it goes down, that's a La Niña.
So the down part is what temperature difference? How would you quantify that?
It's the same. It's more than 0.5 degrees Celsius below the long-term average.
Below the average. Okay.
Yes.
And what does this mean because since these cycles are just always in play, what does this mean overall when it comes to what we see with respect to climate change, the climate crisis itself?
Yes, is the Pacific. Do they see more storms? What do they call them? Cyclones in the Pacific. Like how does someone brace for this, other than it being maybe higher temperature than usual?
Well, interestingly, it's just a natural cycle is the number one objection that people have when they don't want to say that it's humans causing climate to change. But natural cycles go up and down. So natural cycles get warmer and cooler and warmer and cooler. That's like El Niño and La Niña. But human-caused climate change just gets warmer and warmer and warmer and warmer and warmer. So when people say it's just a natural cycle, I say, oh, well, what natural cycle is it? And no one really has an answer because we know that natural cycles like El Niño go up and down and up and down. And so what they do is these cycles have something that we call teleconnections. And that is just basically a fancy word for how this tongue of warm water off the coast of Peru affects weather around the world. And scientists have been able to put that together. And we know, for example, that we are going to see over Australia, we're going to see dry conditions during El Niño, which is not good news for Australia because you remember the terrible wildfires that they had a number of years ago.
Exactly.
So they're going to see.
I didn't know oceans had tongues. This is an interesting anatomical fefeature that I.
It's just anthropomorphized, Neil. It just looks like a tongue.
Oh, I see. So in some temperature map, there's this tongue.
Right.
Okay.
Yeah.
The Gene Simmons of climate. I got you.
Oh yeah, it's a Gene Simmons length tongue.
Okay.
Yes.
All right. So in La Niña, does that mean people actually experience colder temperatures than usual?
Well, in La Niña, again, globally, the average temperature tends to be a bit below average during a La Niña, but a lot of the big impacts come not as much through temperature, but through rainfall. So like I said, during El Niño, it's very dry in Australia and it's wetter across the southern United States. Whereas during a La Niña, it is very dry in California, New Mexico, Arizona, Texas, and it's really wet up in the Pacific Northwest. There's like this dipole effect where it's drier here, wetter here. So these affect, the storms affect, flooding, they affect landslides, they affect the safety of people's homes. The droughts affect wildfires and crop yields. They have profound impacts on all parts of our lives. And again, when we see this natural variability on top of that long-term warming trend, that's when the impacts really add up.
So, Katharine, I have a sort of moral question. So suppose in the coming decades, we have the power to manipulate La Niña, El Niño, and control the severity of the up and down of it, or possibly even flatten it entirely, separate from the ever-rising temperatures that we're creating from our own forces of climate change. What I'm asking is, if we had the power to do that, should we? Or is this so natural to Earth that there are elements of the continental shelves, of the oceans, that actually want this? That there's some equilibrium in that variation, long-term equilibrium, that it needs it and wants it and seeks it out?
That is a very interesting question. And to be honest, I don't even know how you would start to control a natural cycle. I've heard a lot of people talk about engineering the planet for climate change.
Yeah, geoengineering. Yeah.
No, but
that's why it's very hypothetical. So I'm just wondering, does the planet, forget us, does the planet benefit from this? Does it move fishes where they need to be? Is there some is there a place that gets rain that wouldn't have otherwise gotten rain, and so there are plants thriving there? That's kind of what I'm asking.
Yes. So hypothetically, we would not want to do that because natural cycles are part of how the planet balances its heat. So if there's been too much heat building up in the ocean, an El Nino gets rid of some of that heat and pushes it into the atmosphere. If there's too much in the atmosphere, it gets rid of it by pushing it into the ocean. So natural cycles are a little bit like a teeter-totter or a seesaw. They balance out the heat in the climate system.
These are regulating forces.
Yes.
Gotcha. Okay. Because without it, if you took it away, the ocean could just keep getting hotter and hotter, and then we'd have steamed fish.
So, yeah, and speaking of that, seeing as we are, and by the way, now I'm hungry. So since El Nino pushes the heat from the ocean into the atmosphere, what does it say about the fact that we're seeing record temperatures in water temperatures around many places? The Gulf of Mexico, 100 degrees. We've seen the failure of coral reefs all at once. And normally when that happens, there are several indicators that could be making that possible. But what they know now is basically they fried. Like it was a catastrophic loss.
I thought, Katharine, is it unusually warm temperatures that are bad for coral? I thought there was an acidification as well that affects the corals.
Acidification affects them, but the biggest and soonest impact is from high temperatures. It causes them to bleach. Right. And they can be harmed and eventually die. So what we're seeing is to transfer heat from the ocean to the atmosphere, the surface of the ocean has to warm because that's where the heat transfer occurs.
Oh, gotcha.
So that's why we're seeing surface temperatures reach record warm temperatures, especially, like I said, off the coast of Peru all the way across the Pacific, because that's how the heat transfer happens. But there's more going on right now. So for the last 4 or 5 months, scientists have been tracking record high temperatures across the Atlantic as well. And the Atlantic is not where El Nino happens. El Nino happens in the Pacific.
Right.
So what's going on is we've got a couple of different things. So we obviously have long-term human-caused warming. We also have a lot of dust transport from the Sahara. We had the volcanic eruption that happened this past year. And then we've got El Nino changing the weather patterns and the circulation patterns. So we've got 1, 2, 3, 4 things just stacking up on top of each other. And that's why we're seeing record warm temperatures, not just in the Pacific, but over in the Atlantic as well. And like you were saying, Chuck, it was hot tub temperatures off the coast of Florida this past week.
Katharine, so I can summarize your last minute of commentary by saying, we're all going to die. Just to have you add up all of these phenomena together.
It's
bad.
This
sounds, so what are we going to do? We move to Mars? Like, say something positive.
Stop burning fossil fuels. There you go. How about this? Let's start with what we all can do.
I didn't ask you. Katharine, what?
He's right. So I added up all these blocks, and it is really hard to change the impact of a volcano or dust from the Sahara or El Nino. But the biggest block at the bottom is us. And that block is 100% under human control. Okay. And that is why cutting our fossil fuel.
I shouldn't be telling them to shut up.
Yes.
Oh man. Well, in the words of Neil, we are all going to die. So I just want to say that it has been a pleasure serving with you guys. And
this is our final broadcast.
This is where I just pull out my violin and start playing.
And just before we close, Katharine, I understand there's Climate Week coming up in New York City. Is that correct?
Yay. There is Climate Week. And let me tell you.
Is that every year, Climate Week? And
it is everywhere.
At the United Nations?
It does. And there's lots of events that you can listen to online no matter where you are. And 90% of what people will be talking about there is what we can do to cut our carbon emissions, invest in nature, get back on track, because it is past time to put these solutions into action, because we're only doomed if we decide we are.
Okay, all I care about is if heads of states are here, it blocks my traffic flow here. So that's good.
Spoken like a true New Yorker.
What? You trying to solve the world's problems? Yeah, I'm trying to get home from my...
Exactly. Like, why can't we solve those problems in Jersey? Like, why do we have to solve these problems in Manhattan?
In Midtown Manhattan.
Midtown Manhattan? Seriously? Come on.
Well, okay. And what role do you have in Climate Week?
I'm going to be speaking at the opening ceremony, and then I'll be doing events around the city. And again, there's so much online that you can listen to. And let me tell you.
Opening ceremony, you marching in with flags like in the Olympics? What do you mean opening ceremony? What does that mean?
If they gave me a Canada flag, I would carry it. But
okay.
But speaking about why it's so important that we all get together and do something about this, because we can still do something. We are not all going to die, but we have to make that choice today.
Right.
Okay.
Yeah.
All right. Well, we'll look for you in the video recaps of climate. And we're delighted that you're not only a scientist, that you have a voice that is out there trying to make a difference in the world. And not every scientist has that privilege, really. And so it's a testament to the fact that when you speak, people want to listen. Or better yet, when you speak, people understand what you're saying.
Yeah, there you go. How about that?
I admit I went slightly before mode of natural variability, but hopefully that was the only technical part.
Yeah.
Well, Katharine Hayhoe, thanks for being back on StarTalk for this explainer on El Niño and La Niña. Chuck, always good to have you, man.
Always a pleasure.
This is Neil deGrasse Tyson closing out our explainer on climate, El Niño, La Niña. As always, keep looking up.